In this video, we will discuss about superposition theorem for AC circuits. We already discussed superposition theorem for DC circuit in my previous videos. You can take a look at that. But still, let me give you a small intro to superposition theorem. When we have two or more sources, for this case we have two sources, two current sources are present in the problem. So when we have two or more sources in a circuit, we can keep only one source at a time by removing the second source, which means for rest of all the sources. So by keeping one source, we are going to find out whether it is a voltage or current through any branches, and then we have to remove the first source and we have to keep the second source alone, and then we'll do the same analysis to find out whether it is a voltage or current. Finally, by adding all the values which was contributed by individual sources, that is the final result of any voltage or current through the particular branch. Okay, this is superposition theorem, and you can take a look at the my previous problem for DC. So for this case, we have considered AC circuit, and this is one of the practice problem from the Wiiliam Hayt book. So if you are good at solving circuits, we can directly apply superposition theorem on this particular circuit. If not, we can simplify the circuit. Simplifying the circuit is, if you have a parallel combination, you can first combine these things, parallel combination or series resistors. You can add or do the parallel combination to find out or combine these two branches. So when I have resistor and capacitor or inductor, we can call it as a impedance for this case. Okay, and that is why we have given Z1 over here. Okay, so I'm going to do a simplified circuit first. So first I'm going to combine all these branches because they are parallel branches. How it is parallel? Because starting point of these two branch, ending point of these two branch are same. So we can call it as a parallel combination. Now we are going to apply parallel combination. So first let us consider 5 minus J10 branch, which means this branch. So we know the parallel combination, how it takes place. Parallel combination means multiplication of these two value and divided by addition of these two value. So this is only a real number, so I have given complex number is 0, and here you have only complex number, so I have given only 0 for real number. Okay, so multiplication over here divided by addition of these two number, 5 minus J10. Okay, so whenever we have multiplication, it is always convenient that we use polar format for multiplication and division, and when we have addition subtraction, we can go with the rectangle format. Okay, so here we have multiplication and division. So what I'm going to do is I'm going to convert the first one into its polar form, 5 with an angle 0, and then if you convert this into polar form, you will get 10 with an angle minus 90, and you can use calculator to convert rectangle to polar, polar to rectangle conversion, and that example also I have given in my previous videos. And similarly for 5 minus J10, this is the polar format. Okay, and if you multiply 5 into 10, you will get 50 divided by 11.58 over here. Okay, and whenever there are angles in division, then you can bring the denominator to the numerator side with a sign change. Here it is minus 63, so you will get plus 63 value in the angle. And normal division happens here, and normal division value will be 4.47 and with an angle of 26.57 after adding these two. And in rectangle format, the same value will be 4 minus 2j. Okay, in the same way, if you do for minus J5 parallel 10, minus J5 parallel 10, the value is 10 with an angle minus 90, or in rectangle form it is minus J10. And for the third case, J5 and 10, you will get J5 10 combo will give you 4.47 with an angle 63.44, or in rectangle form it is 2 plus 4j. So after simplifying, which means combining parallel resistors, this will be the circuit. Okay, so we combined first two resistors and the value is 4 minus 2j from here, and then minus J10 from here, this combination, and final combination is 2 plus 4j, and this is 2 plus 4j, and we have added the actual source value. Now we are going to apply superposition theorem on this. So according to the superposition theorem, what we are going to do, we are going to keep only one source at a time. So for this case, we have kept only first source, 1 with an angle 0 source alive, and by removing the second source. So whenever there is a current source, you need to open circuit it. Whenever there is a voltage source you need to short circuit it, and the reason we have already discussed in my previous videos. Okay, so now once you remove the other sources by keeping only one source, we can apply any convenient method, whether it is a nodal analysis or it is a mesh analysis or current division rule, voltage division rule, whichever is convenient to you, we can use that particular method to find out the required voltage or current. So from the given problem, we are going to find out V1. So V1 contributed by first source, and similarly V1 contributed by the second source separately, and finally we are going to add the result. That's all, very simple. So here what we have done is, I have applied current division rule over here. So first what I have done, I have combined these two resistors because they are in series combination, one after another the connection is. So the combination of these two will be 2 minus J6, and I have replaced 2 minus J6 over here. And now I have applied current division rule. So according to current division rule, if you want to know what is I1, then the actual current into opposite resistance, total opposite resistance, divided by total resistance of these two branches. First, this is the actual current, and this is opposite resistance 2 minus J6, and 6 minus J8 is nothing but combination of these two. So 4 plus 2 will be 6, minus 2J minus 6 will be minus 8. And if these two are in division, so you are going to make it as a polar form of this, and similarly polar form of this, and by doing mathematical operation by division and subtracting the values, I1 value will be 0.632 minus 18.43. So we know what is I, and we want to find out what is V. So V is nothing but multiplication of I into the resistance corresponding impedance value 4 minus 2J. So multiplication is here, so we have converted this 4 minus 2J into polar form, and whenever the values are in multiplication, you are going to add these two angles. Okay, angles are added here, and this real number is just a magnitude number, is just like a normal multiplication, nothing else. Okay, so normal multiplication of these two will give you 2.82, and angle should be added, so your value will be minus 44.99, approximately will be 45. This is V1 due to the first source alone. Okay, the similar way we need to find out V1 by keeping the second source alone, by removing the first source. So the second page, okay, third page, that will tell you with this source. Okay, and the notable point is here you can see the arrow mark is going down. So whenever I consider current direction as upward, which means here and here, from here, then I need to put minus in front of the actual value, because I assumed the current direction is this way. Got it? Not this way, but actual current is going downwards, so I have added minus sign over here along with the actual value, and actual value and opposite resistance. So what I want to find out, I want to find out I2 here, because we are going to find out what is value at this location across 4 minus 2J, across 4 minus 2J. So I want to know what is the current value flowing through this, and there is a correction, this is V1 not V2, this is actually V2. Got it? So for this case we are going to find out voltage drop across this one. So what is the opposite resistance? 2 plus 4J, 2 plus 4J is here, divided by sum of opposite branch along with the same branch. Okay, so 2 plus 4J minus J10, 4 minus 2J, all the numbers are appearing here, and after adding you will get 6 minus 8J, and the numerator 2 plus 4J, and then again it is a mathematical calculation, convert this into polar form. Similarly this is polar format over here, and combine angles. If they are in multiplication, add those value. If they are division, you can subtract the angles by changing the sign. Okay, and final result will give you the value is minus 0.223 with an angle 26.56. And to get what is the voltage V2, this is actually V1. Okay, across this will be I into the resistance value, which means impedance value. I2 value is here, so this is I2 value over here, and polar form of this is given here, and after multiplication and addition of the angle, that leads to minus 1 plus J0. So finally, according to superposition theorem, we need to add the total values, which means first V1 and first V2, and the result will be 2 minus 2J, which was contributed by first source due to one angle, and then second value is minus 1 plus J0, so minus 1 plus J0 here. Combine real term and imaginary term, that will give you 2 minus 1 is 1 and minus 2J here. So this is the voltage drop across the particular branch in a rectangle form, and this is in polar form, which means this value. Okay, because parallel drops are same, so the same value V1 here and the same value is over here also. Okay, similarly V2 value is same here, V2 value is same in the two branches. Got it? So that is why we have combined these two resistance where there is no change appear in the voltage. Okay, this is all about superposition theorem for AC circuits. Thank you.